Most of you know me through .NET Oxford, but because this is very kindly been recorded on YouTube by Pusher, I'll still do the usual introductions. So my name's Dan Clarke. I'm an independent software developer, so contractor, freelancer, consultant, that kind of thing. I've been developing for over 20 years. The first half of it has been in the games industry, doing C and C++, and then the latter half has been doing more .NET stuff, so web, desktop, not so much mobile, but mostly web and desktop architecture stuff, and now doing more cloud stuff. Everstack is my company, which Matt mentioned earlier. So this is just a limited company I put all my contracting work through. At some point I'd like to expand and become a bit more of an official company, but at the moment it's just me. .NET Oxford you already know, because you're here, but for people in YouTube land, we've been around for about 2.5 years. We have monthly meetups, and we've grown into a fantastic .NET community. So if anyone's listening in YouTube is in the Oxfordshire area in the UK, it'd be great to see you here. As Matt mentioned as well, Azure Oxford, so this is a new user group started by myself and James World, and we had our first meetup about 2 weeks ago, and lots of great feedback, and we'll be having monthly meetups there. I've got a blog, danclarke.com, quite a few in-depth blog posts of .NET Oxford and various other stuff. I've got quite an in-depth blog post of this talk tonight, which has all the details, including links to all the hardware stuff, and basically everything I'll talk about tonight. So I will tweet out a link to that later. So the agenda. So we're going to start off with a hardware overview, because I'm sure most people are interested in what's down here. Then we're going to basically create a basic .NET application. So this is going to be so an ASP.NET Core web app. We're going to have a .NET Core console application. When you click a link in the web app, it's going to pop a message onto RabbitMQ. The console application is going to be subscribing to the queue, and when it receives a message, it's going to send a message to Slack. So really, really simple. But because we're talking about Docker, Kubernetes, containers, I wanted something very simple that had multiple components, including a third-party component, just to help with the demo. But you can imagine, it's obviously in this kind of thing, you wouldn't have a message queue, but imagine this being a very busy order management system, an e-commerce website. And so the customer goes to the payment page, they create an order, the order confirmation page, they create the order, rather than the actual website having to do the payment gateway and communicate, do all the payment stuff, and then send emails out and various other things you've got to do. You can imagine you've got worker services, so different microservices, taking a message off the queue and doing that work, and it takes the load off the website. The website can be, so as soon as you create the order, it's popping a message onto the queue. The message is just a blob of JSON. So it's a really lightweight bit of data, that's all it is. So it just means it kind of does the whole single responsibility thing where you've got different services taking that responsibility. Once you've put the message on the queue, the website can just, its responsibility is finished with, it can carry on doing its thing. So once we're going to create that application, we're going to run it locally out of Docker and then inside Docker, then using Docker Compose, and I'll explain what those things are as we go along. Then we're going to have a short break, so a 10-minute break in the middle, and then we'll be doing an intro to Kubernetes. So we'll be talking about all the terminology for Kubernetes and generally what it is and how it works. Then we'll be talking about installing Kubernetes on the hardware. Now, I've already pre-installed it because it would have been taking too long otherwise, but I'll be SSHing onto the Pis and talking through everything I did to actually set this up. Then we'll be running our application on the Raspberry Pi cluster, and hopefully the demo gods won't come into play, and hopefully this will all work. The last time I did this talk, the only time I've done this talk before, at one of the DDD conferences, 5 minutes to the end, this thing, my MiFi device, ran out of battery 5 minutes before the end, so hopefully that won't happen this time. I've got this plugged in, so it's charging now, so we'll see. So why? Why would you do this? The answer is you wouldn't, unless it's a hobby project. Scott Hanselman did this a while ago and did a blog post, and I quite fancy it. I'm quite into Docker and Kubernetes, obviously, and I fancy just giving it a go. In real life, you would use, so if there was no reason why you shouldn't be in the cloud, you could use, you'd use like some managed Kubernetes cluster. So Azure's got AKS, Azure Kubernetes Services. There's some other cloud providers, I believe. So like, obviously Google, Kubernetes came from Google, so you've got Google Cloud, you've got AWS. They've all got managed Kubernetes services. So if you can do it in the cloud, don't try and do it yourself. Just click on a button, you can create a cluster. If you have to do it on-prem, whether that be on physical machines on-prem, VMs, whatever, then obviously you probably wouldn't do it on Raspberry Pis, but a lot of the concepts I talk about are the same. In fact, a lot of the concepts I talk about are applied to, even if you're doing it in the cloud as well, because I'll explain containers, Docker, Kubernetes and stuff. For Raspberry Pis, the first one, so in Kubernetes term, you generally have one that's called the master, and that's generally the brains of Kubernetes, and then you have other, they're called nodes, which I'll talk about later, which are other machines in the cluster, and they're basically where you run your containers on. So we've got each of those, and then we've got the case, which is a stackable case, so you can really pile up, you can stack them as high as you want, as long as it doesn't fall over. So we've got this stackable case. Can you see it from there? Right. So you can stack these up as high as you want, as long as it doesn't fall over. Then we've got this is a travel router. This is really cool because it can connect to an external Wi-Fi or wired. And on your internal network, you can have an internal Wi-Fi or wired. So that means depending on where I'm doing the talk, so I'm doing it here, I'm connected to it's connected to the Wi-Fi here. When I did the talk at DDD, I was connected to this MiFi device, which I'm not actually using at the moment. That's the one that the battery ran out, and so that's there as a backup just in case. Then we've got, so internally, this one, if I wanted to connect to an external wired network, I could plug in here, but I'm connected to the Wi-Fi. Then these two are internal for the internal network. And then because we've got 4 Raspberry Pis, this is going to this one, this bottom one, which is a Netgear switch. And then all the Pis are wired into the switch. And then we've got an anchor, oops, it's not working. Then we've got an anchor power block. If I switch over to here, so 4 Raspberry Pis, stackable cases, 4 SD cards, there's the 8 gig SD cards in here, travel router, the network switch. I've chosen flat Ethernet cables because it stops it from getting so tangled up. The anchor power port, so that's just plugs into the power and is charging all the Raspberry Pis. It's charging the travel router and the MiFi device as well, and then the charging cables. So that's the hardware. There's a company called ModMyPi, which I believe has recently been bought out by another company called Pi Hut, I think it is. And they very kindly provided the Raspberry Pis, the SD cards, and the case. The rest is provided by Everstack, but yeah, the Pis are provided by ModMyPi. This is a fantastic company. If you go to their website, and that actually redirects you to Pi Hut now, I found out today. And they've got forums, tutorials. It's an e-commerce website, so lots of things like Raspberry Pi stuff, Arduino stuff. It's a really great site, so I'll definitely check them out. So we're going to start off by building this app now. So I'm going to start from scratch, and we're going to use the .NET CLI. So if we move over to the command line, can everyone see that? I'll just make it a bit bigger. Can everyone see that? Is that a reasonable size? Okay. So we're going to create a new directory called DNO, .NET Oxford, let's call it that. And then using the .NET CLI, if I do .NET new, and then if I just want a web app, I can do MVC and then output the project name, so I'll call the website web. And that's all you need to do. So this is the same as in Visual Studio. If you go to File New, but I find it a bit quicker. You can just do that and create a new website quite easily. And then, so that's given us that web directory. And we can do it exactly the same if we do console, and we can create the worker thing. So immediately we've created these two components. So the O switch is the output, so that's basically the project name. So you can see that if I do a directory here, we can see we've got web and worker. Can you see that from there? So basically it's created a new directory and that's the name of the project. So if I open that up in VS Code, so it's using VS Code for the current directory. So we've got a standard web app. So it's kind of pretty standard. You've got your home controller, you've got your views, and then we've got the worker, which is a standard. It's just a standard console application. The next thing we need to do is, because we know that we're talking to RabbitMQ, we need to add the RabbitMQ NuGet package. So NuGet, for those that, are there any non.NET developers here? So a few. So for .NET, NuGet is the package manager. So any libraries you want to add, any third-party libraries, or you can have private NuGet packages as well. That's in the same way with Node. You've got npm. It's the main package manager. So we can do that using Visual Studio, the NuGet package manager, or we can do it again with the command line. So if we go to web, we can do .NET. So again, using the .NET package manager, add package, RabbitMQ.client. So this is the official .NET client for RabbitMQ. So I just find this a bit quicker than having to manually go to the NuGet package manager. And then we can do exactly the same again in worker. So very quickly we've added this NuGet package to both web and worker. So we've got this has got the NuGet package now, and so does this. So what I'm going to do is, if we go to the web, you can quite easily run this if we just do .NET Run. Yeah, so the question was for the video, can you create a solution file from this? You can. So those two projects obviously just have CS proj files. You can do, I think it's .NET new SLN or something. There's definitely a command thing, and basically it looks in the current directory for any projects and it automatically adds it. Well, we can try that now actually. If we go to .NET, I've not done this in a while, something like that, or it might be SLN new. Is it new? So we've immediately got this, and it's .NET. I can't remember. Who called out? Can you remember what the syntax was? It's something like .NET add. SLN add web. So you can do. Yeah, so we can do that. So we can do that, and immediately we've got a solution file with that, and that's the standard solution stuff. It's been a while since I've done that, so I forgot. But cool. So if we go back to the web and we do the .NET new run again. Then, so this is now listening on localhost 5000, and if we go to here, 5000. So this is like the basic web app when you do a .NET new. Rather than creating a whole new hyperlink, I'm just going to hijack this privacy link. So when you click on this, that's when it's going to pop. That's when it's going to do putting a message onto the queue. So if we go to web, if we just go to home controller, so I'm just going to put it into here. So I've got no one wants to watch me do lots of typing, so I've got a few. Here's one I made earlier, so I'm just going to copy it in. So if I save that, pop that into web, and I'm going to save this into both web and worker. Right, so anyone that came to my talk, my lightning talk a few months ago on dependency inversion and IOC containers, don't shout. So to make this really simple, can everyone see that? To make this really simple, I've made it a static class just to make it really easy to understand. Don't do this in real life. Why can't I zoom in? But don't do this in real life because it means the code that's calling this isn't very testable. But I'm not writing unit tests, I'm being naughty, so just don't tell anyone. In here, the key classes, we've got a send and we've got a subscribe. So the send, you give it a queue name and a message you want to put in. Message generally would be a bit of JSON, but in this case I'll just do, it could be random text, it doesn't matter. The subscribe method takes a queue name and takes a callback function. And then that, so we want to send a message, obviously we use that. If we want to subscribe, we pass in a function, and then that function will be called when we receive a message. So the idea is that this is calling the send, this is calling the subscribe. Okay, so I've added this, and because we've added the NuGet package before, that should work. So if we go to home controller now, all I'm going to do is that send, give it some random queue name. So you can publish, pardon me, you can publish to different queues and you can subscribe to different queues. So in this case, let's do hello.net Oxford. We also in here, we've got an init method which we've got to call. So I'm going to put that in just at the very start of the program. And that is the web app done, because as soon as we click the privacy link, that will pop a message onto RabbitMQ. As far as the console application, I've cheated again, and I've got another, here's one I made earlier, I've got a Slack helper. And again, I'm sorry, this is a static method again, don't shout. So I'm going to save this into here, and all this is doing is, it's basically sending an HTTP request. So there's nothing exciting, it's just sending a message to Slack. I won't scroll across, so those people on YouTube can't spam me with Slack messages, but and then all I'm doing is taking that message and posting that to Slack. So hopefully, when we click on the privacy link here, it'll pop a message on the queue. This will then pop a message to Slack, and we'll get a notification pop up here. So that's the idea. So it's a really simple kind of thing. That's done. Slack helper. So if we go to this program, which is just doing hello world, and I copy over a program that I created earlier. So this is quite simple. We're just doing the initial init. We're doing we're calling that subscribe method with the anonymous method. So our callback. So we're just going to write a message to the console, to the output, and then we're going to call that send Slack message, and where X is that message. So X is the message that's been put onto the queue, which has been passed down here. And that's it. Then we're going to just sleep and wait for messages coming in. So it's really, really simple. Hopefully, we're actually missing one more piece now. So that's all. And that's now in place. The code for this is now in place. Hopefully both compile, but we're missing this. Now this is where Docker comes in, because we could install not Kubernetes, we could install RabbitMQ locally, but given that we're planning on installing these in container with Docker on Kubernetes, we may as well use Docker from the start. So let's just compile that. So can I just show a show of hands who's used Docker before? Who's not used Docker before? Who doesn't know what a container is? So most people know. Well, do I explain what a container is for people that are listening to the recording? So a brief explanation of containers anyway. Just everyone here knows containers, but as it's been recorded. So there's a couple of ways you can think about a container. One way is you can think about it as being a really, really lightweight VM, which is designed for just one process. And I say VM because it feels like a VM. You've got a virtual file system, you've got a network layer, you can connect to it, so it feels like you can SSH into it and you can browse the file system. But it's designed for just one process. Another way is you can think about it as a wrapper around that process. So the container's lifetime is the same as the process's lifetime. So if you're running RabbitMQ, that process is RabbitMQ. If you're running a console application, that process is your console application. When your container starts, that process will start. When your when your process dies, so if it's a clean exit or an unhandled exception, then the container will go away too. So it's all about that one process. And all your local dependencies, so like NuGet packages, if you're using .NET, if you're using if you're using Node, so your NPM packages, the language runtime itself. So if you're using .NET, the .NET's runtime is actually running inside the container too. If you're using Node, the Node runtime is running inside this container. So the idea is that if your container can run on your machine, ideally it should be able to run on your colleague's machine in dev, UAT, production, and because all the local dependencies are part of it. But you can't take a container and put it on another machine because a container is a running instance. And this is where a Docker image comes in. And a Docker image is a snapshot of a container. And so you can think of like that's on the file system. You can copy the Docker image to another machine, and your colleague can then spin up a container from that image. So you can copy those files, but in general you don't copy a Docker image from one machine to the next. You use something called a Docker image registry. And in the same way as with Git, where you make a change, you push and pull, Docker's taken the same terminology, and you can, if you're building your own images, you can push that to an image registry, and someone else can then pull that image and then create a container from it. So an image is like, think about it as a template. A container is a running instance of an image, and you can take that image and you can push it to a remote image registry to share it, and then someone else can pull it down. So that's the general idea. The default image registry, you can create your own image registries, and you can spin them up at a click of a button with Azure, various cloud providers. You can run them on-prem. The default one is called Docker Hub. So if we just jump over to hub.docker.com. So this is the default remote image registry. And we can see here, let's make it a bit bigger. We can see here 2.5 million images. So it's huge, there's so much stuff in. And here I'm sorting by most popular. So we've got stuff like Oracle, and there's various databases, Redis, Mongo, Ubuntu, Postgres. So you can see there's lots of stuff on here. We're interested in RabbitMQ, obviously. So if I type type RabbitMQ, official image, go to RabbitMQ. How likely are you to recommend Docker Hub? I'll say extremely likely. No, I don't want to send anything, just go away. So you can see here, we've already got, it says to pull this image down, you can use the Docker CLI, which is how you interact with Docker, and you can do Docker pull, the image name. So we can, if we go over to the command line now, if we just clear, we can do Docker pull. By the way, if I type that, I've got an alias for D for Docker. So if I arbitrarily type that, it's just the same as typing Docker. It's not there by default though. So we could do Docker pull RabbitMQ, and that will pull down that image. If I just want to run it straight away, I could just do Docker run. And that would, if I've not got it on my machine, it'll pull it down, and then it'll run it. So Docker run creates a container from this image. You've also got a concept of tags or labels. So if we go down here, we've got supported tags, and these can be different for all different images, but generally it's used for versioning. So if you've got the same, so obviously the RabbitMQ, there's lots of different versions, and we can see the different supported versions here, and these are called tags. They've also got a management tag. So the tags don't have to be just about versions. They're, like in this sense, they're using management for the RabbitMQ image that includes the management dashboard, so we'll get that version. So I'm just going to use this tag, and to specify that, all you do is do colon, then whatever it's called. So I'm going to grab this tag. So it's that version of the image. So I could run this now, and it would download the image, and it would create a container running RabbitMQ. I wouldn't have to install it; it would just be running. The problem is I won't be able to use it because there'll be no ports accessed. So the next thing I need to do is expose a port. And if we look down here, we can see that the default, I can never remember it, the default RabbitMQ port is this one. So basically I do that. So P stands for publish, and I think about it as port because that's easy to remember. The number after the colon is the port that's inside the container that RabbitMQ is listening on, or whatever the software is that's listening on. So that generally has to be what the software inside the container is expecting. The number before the colon can be anything you want, pretty much. This is how you access it. So I would access this on my computer via localhost colon this port number. So I could make this something else, but I'll keep it the same anyway. So the next thing is I mentioned about the management console, and so I need to expose another port here, which is exactly the same, but they've got ports. So that's the port number. And they do, in the documentation, generally on the homepage of whatever software it is, they generally have various references, how to use it and stuff. So it'll mention the management port, the management image, like here. So if I run this now, so images are actually cached. So if hopefully they've not done an updated version since I last did it, but so that's now running RabbitMQ locally. So I've not installed it. If I Control C, it'll, if I not Control C, if I kill the container, then it won't leave anything in the Windows registry or this kind of thing. It's just I'm using it and then I can throw it away. So if I go to localhost and then that port number, then now, so we've immediately got the RabbitMQ dashboard up. I think the default is guest, and then we've immediately got this RabbitMQ. We've got no queues created, but now we've got this running. It's a bit smaller. So now we've got this running, we can run our website, our console application. So if I create, and those that haven't used this before, this tool is a tool called Commander. It's built on top of ConMU, and it's basically a management tool that allows you to embed command prompts effectively. So you can run PowerShell, CMD, Bash in these, and it adds lots of extra functionality, like being able to do the split screen thing. So I can do another one down there. So that's really powerful. And you can have various tabs, and it's got lots of extra functionality, so that's worth checking out. So if we go to DNO web, and we can do .NET Run here, and then in here we can go to, can everyone see that properly? Is that okay? DNO worker, and then do .NET Run. So here on the left, obviously you want to have this font this big, but just so you can see at the back. We've got the RabbitMQ output running from Docker container. We've got the website which is now listening on localhost, which this isn't running in Docker at the moment. And then we've got the worker which is connected to, it's successfully connected here, and it's waiting for messages. So hopefully, if I go to localhost 5000 or 5001 for TLS, hopefully if I click on here now, then nothing's going to happen. So it's received a message, so it's received it, so it's probably just my notifications. So you can see how that's appeared there. Okay, so if we close this now, then the next step we want to do is we want to run this in Docker. But to do that, we've got to build our own Docker images. So how do we do that? So going back to here's one I made earlier, we've got something called a Docker file, which isn't selecting, thank you Evernote. Oh, there we are. So if I save that now, so we're going to save this in the web, and we're going to save another Docker file in the worker. And then go back over to here. So if we look at the web Docker file, so if you want to build your own Docker images, you do so with a Docker file. And basically this is a list of instructions telling Docker. So what it does is, we'll start off at the very start. So we've got, in fact, let me make it a bit bigger. There we go. So a Docker file always starts off with a from command. So this is specifying a base image. Now a Docker image is layered. So you'd always start off with a base image, and in this case, this is Microsoft's .NET Core SDK. And if we actually go back to Docker Hub and search for, .NET. So we've got these different repos, and you can see that I'm using .NET Core SDK, and then this tag. And then so if we go to the SDK version, so I'm using this as the base image, but if we search for Dockerfile in here, we can see that this base image has actually got its own Dockerfile. So if I just pick one at random, and we can see it's on GitHub, I make that a bit bigger. So you can see that has got a from as well. So the Docker file that I'm basing my image on is based on Microsoft's Docker image, which is based on a Debian. And if we go to this one, it's probably based on another one, all the way down to some container OS, like the native Debian image. And you can see that we've got run commands, which basically run. This is a Linux container, so it's just doing apt-get. So for those used to Linux, it's just doing the apt-get to install stuff. And so these are like the run instruction is just telling it to run these commands. And what it does is it creates a container from this base image. So the same way as we're doing a Docker run. So I should go back actually. If you want to build this image, you would do docker build dot and dot. Basically, this expects there to be a Docker file in the current directory, and it'll build it. So when you do that, it'll create a container from this base image, and it'll work through, and the run commands, it'll actually run those in the container. So we've got work directory specifies the current working directory in the container. Copy takes all files from the current directory you're running this command in and copies it into the current directory of the container, this working directory. And then we're using the run to just run commands on the command line. And because we're basing this off the SDK, this has got the .NET CLI installed. So it's the same as in the command line, in the container, me doing .NET restore, because I'm using the run. And then we do a .NET publish, doing a release build, and then we're going to publish that. And that'll put it in the current working directory, source bin release. Now the thing is, we've got two, you notice we've got two froms. And this is actually really, really cool, because this is called a multi-stage Docker file. And so one problem, if I could just do, so if I just move, I could just do this. If I move that up there, let's comment out this. Let's just move that, move that. So I could just do something like that. And basically that would create the container, do all this. The entry point, do you remember before how I said that a Docker container is all about one process? That's the one process. So in this case, the process, because .NET Core, when you actually run it, it's actually running the .NET Core process, and your application is a DLL. So the process in this case is the .NET runtime. But if it was like a C++ application, it would be your executable. The problem with this is that that image is quite big, because it's the SDK, it's got all the .NET tools in. You don't want to ship that to production. So this is why we've got if we undo all that now. So what this does is, within the same Docker build, the same Docker file, just these few lines, which is obviously source control, you'll see the from has as build here. So that's giving it a name. And then this second bit, which is going from a much more lighter weight runtime Docker image for just the runtime ASP.NET Core. It's going to take that as the base image, set the working directory to app. It's going to copy from build. So that was the alias at the top that we saw before. So it's going to copy from the top container that was built using the SDK base image. And then it's going to copy from that folder, not the .docs, which is what .NET publish publishes to, and then it's going to copy it to the current directory in this container, which is that directory. And then it's going to do the expose and the entry point. So that means that doing Docker build on this is building your application. You could do .NET tests, so you could run all your unit tests as in this first lot. So your CI/CD system could be just doing a Docker build. That could be building your application, running all your tests, and then taking the artifacts of that and basically building a production lightweight image that we can use in production. So it's really, really powerful using that. So now if we want to build that, hopefully, I should explain as well, I've got a few commented out bits, which I'll come to later, and that's because when we compile it to run on the Raspberry Pis, we need to change the runtime to the ARM processor. But we'll come back to that later. So now if I do Docker, in fact, before doing that, let's just explain Docker compose. In fact, no, let's try running this without Docker compose. So if I do Docker build dot the current directory, and do that in here as well. Hopefully that's worked. So you can see it's doing all the individual things. The steps we've done the copy. We're doing the NuGet restore. I've never tried building two at the same time, so just in case, I'll wait. So let's build the other one. And also what you can do is when you do a Docker build, you can do -t and give it a tag. So, and these labels we saw before, so I could do like whatever to give it a name. It's already built it so that all of those were cached. And if I give this, I should have said, let's say worker. And then I can do Docker run. And remember, Docker net, what? Docker run. And then we can do the blah. So obviously these images are running local. I've not pushed them anywhere. And hopefully this is going to run. That didn't work. Right, so one more change we need to make. Okay, so if we're going to save this Docker compose, and I'll explain what Hubert's explaining, what I'll talk about in a sec. So I've just saved this Docker compose file. And basically this, just make it a bit smaller. So this is a YAML file. And imagine you've got a whole bunch of different services. You don't want to be doing Docker build, Docker run for each individual one. And so a Docker file, a Docker compose file allows you to specify a configuration. You can source control this. You can obviously push it to Git. You can see the history. But this describes each service. So we've got the web here. And we can specify the image name, which is the tag we mentioned. Also, the image name, but then you could specify a tag name, so we could do blah here. And the reason I'm prefixing it with Drakan here is because my account in Docker Hub is called Drakan, and Docker Hub expects that in the image name if you're pushing to a personal account. So when I do a Docker push, it knows that I'm pushing to my account. The port numbers, exactly the same as what we did on the command line. And then you can say it depends on another service. And we can see here that's what we did before when we run this. So the idea here is I want to run all of these in one go with one command without having to do Docker run on each thing. One thing to mention that, and this is basically what Hubert was talking about before, so and the reason why this didn't work is because we're running this inside a container, and in here, do you remember in the RabbitMQ? We're using a local host. So if I run this in .NET Run, then this is the local host is my machine. If I'm running it inside a container, which is a sandbox, which has its own network layer, local host inside the container is inside the container. So that there's nothing, RabbitMQ isn't running inside that container as well. But in a Docker compose file, whatever name we give each of these services, inside this Docker network acts as a DNS entry. So what I can do is, because I happen to have called this RabbitMQ, and I can call this anything I want, I can then go back to here, where were we? And change this to RabbitMQ. So I can use that as the DNS entry. So I also need to change this in here. Cool, I think that's good. And then if we do, so what I'm going to do is close each of these. It's going to close. Hide that away until it closes. Stop this one. So if we do Docker Ps, we can see what containers are currently running. I want to get rid of that now because I want to run it in Docker Compose. So I can do Docker kill, specify that, get rid of that container. So now if we do Docker PS, we've got no containers running at all. If I go back to the directory that we have our Docker Compose, I can then, commands I would do Docker something to, for individual ones, I can do Docker Compose, say Docker Compose build. I've got another alias, Docker DC, so I would recommend, if you're using this a lot, create an alias for D for Docker, DC for Docker Compose. Kubernetes I'll talk about in a bit, but there's a command line tool called kubectl. I've got K for that. So I've got G for Git. Just make, if you're using the command line a lot, aliases are really powerful. So what we can do here is we can do Docker build. And that's going to go through each of those services. You can see it's skipping RabbitMQ because that's not our own image, it's a third-party one. How is it 8 o'clock already? So this is going through building each one of those. And then hopefully what we can do is, if we do Docker Compose up, so up basically spins up everything in your Docker Compose file. And if we hadn't already built it, we could have done that to explicitly say build as well. So if we do this now, what this does is, we've got an error, what's this? Nice. So sometimes you see this when there's nothing else running. Docker for Windows does a weird thing where, I thought I restarted Docker, but when it starts up, sometimes it gets into that state. I'm hoping that's what this error is. But I'm sure I restarted it before, so that's annoying. So I'm hoping when I restart. And unfortunately, Docker for Windows, it's called Docker Toolbox, Docker Desktop now, sorry. It takes quite a while. As you can see down here, you've got this animated thing. So this will take about 30 seconds. So in fact, while that's going on, I'll explain options for Docker for Windows. So you've got, I understand your question. So basically the 15672 refers to the console, the dashboard. This is the one that our website and the worker processor listen to, which isn't any different. So if I wanted the dashboard, so when I get this running, if I want to see the dashboard, rather than going to localhost that to see the dashboard, I would have to go to localhost this. There's no reason why I've chosen different. I don't know why, but the point is you can have whatever you want on the left. That's just how you access it. And so hopefully that's now. Thank you for the question, because that's filled the time with Docker restarting. And I'm impressed you remember that number too. I can never remember that number. So hopefully, please work. Yeah, very true. Very true. Very. So it's just this one, isn't it? Let's try that again. 8081. So let's just get rid of that because you've already seen the. Let's just ditch that. Good. You've already seen the dashboard. Can we cut that bit out? Right. So Docker Compose is. Can we move that fan over here? So Docker Compose basically runs all these services together. We can see that we've got different colors for each of the different services. So if we go to the Docker Compose file, you can see that I'm specifying restart always. So I'm kind of, for this demo, I'm relying on that, and you can see that there was quite a few exceptions here because RabbitMQ hadn't started. So it couldn't connect to it, so it threw an unhandled exception. In real life, you'd have retry logic using something like poly, but I was relying on, until RabbitMQ was successfully started, it would, the website and the worker process would just throw an unhandled exception, and Docker would restart it again. And now we can see that RabbitMQ started, worker is waiting for messages, and web is listening. So now, hopefully, the next bit, if I can't go to the management console, if we go to Docker Compose, we can see for the web, I've specified 1, 2, 3, 4, which is inside the container, it's going to be 80. So if I go to localhost 1, 2, 3, 4 now, so we've got our website running, and if we go back to here, we can see, I think this is running in production, so it's not doing lots of logs. And then if I click on privacy now, and go back to here, we can see it's received one. It's annoying that we're not getting this pop-up, but you can see it's showing another one here. I was hoping we'd get lots of pop-ups coming up here, but I think it's because it's plugged into the projector. So if I just do a whole bunch of click, 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 then we're getting a whole bunch of messages and we're doing lots of receives. Cool. So that's now working in, we've explained Docker Compose, we've explained containers, Docker images, Docker image registries. We've had this running just using the .NET CLI, using just not just using Docker. We failed with that one, but we know why. And we've had it running with Docker Compose. So the next step is we want to build this in preparation for after the break. We're going to run it on the Raspberry Pi cluster in Kubernetes. So I mentioned before the commented out sections in the Docker thing. So the only change I'm going to make is change that. So the only difference here is I'm doing -r, so specifying the Linux ARM runtime. And I'm going to change this over. So this is going to use the ARM version of .NET, the .NET image. I'm going to change this one over. Oops. So this is so the only difference with this one is that when you do a .NET publish for ARM, it adds another subdirectory here. So that's the only difference there. And I think that's all we need to do. And then, so if we go to, let's close this off. If we go to the worker Docker file, which I've not shown, but it's very similar. And the only difference is that the runtime image is not ASP.NET, it's just .NET Core, because it's not an ASP.NET application. And the name of our DLL, I think that's the only difference. So again, in here, I'm going to change over there, and change over there. Okay? And again, leveraging this, I'm just going to do a .NET build. So close this down. And you see in the Docker Compose, if I do Control-C, it's stopping those containers now, so these are no longer running on the machine. So if we do Docker, so now we've changed that, we can do build. So that's it's detected changes to the files in that directory, so it's going to rebuild stuff. Some things like the from, it's going to cache, the working directory, it's going to cache. So as it's doing this build, because Docker's building this is layered, like different Docker images. So up until the point where it's changed, which in this case will be the copy, it'll cache those locally. So structuring your Docker files so the things that change most frequently are further down the Docker file means that much more gets cached and you're not recreating lots of image layers. So once this is done, we'll do a Docker push. This will take the two images we've just built and push it to Docker Hub. So if we go to Docker Hub, because I'm logged in, hang just make that a bit smaller so I can see what I'm doing. If we go to my repositories, oops, no, that's GitHub. Oh, sorry, why am I not on Docker Hub anymore? That's what I was after. So you can see that I've already pushed some before because I don't want to push. It would take too long and I don't trust the internet connection to re-push them all. But basically we're going to push a new version on top of that. So that's now built. We can do doc compose push. And then this is then going to push. And we should hopefully see that it's saying, because I said that layers are cached, that we're not. So one key point here is, even though some of the Docker images are quite big, if you're doing lots of pushing and pulling, you're not pushing and pulling these big massive image files because they're layered. So you can see that this might take a bit longer, but a lot of the bigger layers will already exist. So now we're going to start by talking about Kubernetes. So we've talked about Docker, containers, and all that kind of stuff. We're going to go through some terminology in Kubernetes, which is like the fundamentals of it. So we're going to start off with a pod. So a pod is basically, for what we've learned so far, you can almost think of a pod as a container, but really a container, it lives in a pod. A container is inside a pod, and you can have multiple containers inside a pod. The pod is the lowest thing that can be deployed to a different node in your cluster. So, for example, another one of the Raspberry Pis. Generally, for basic usage, you'd have one container inside a pod. The use cases where you might have a separate container inside a pod might be, you might have a different container which is in charge of logging, taking logs from your main container in that pod, and then doing something with it. So that's called sidecarring. But for the scope of what this beginner intro talk, imagine there's one container in a pod, and really you can think of a pod as a container for the scope of this talk, but it's not. It's a wrapper. It holds containers. A deployment. So a deployment is how generally you wouldn't explicitly create a pod. You would create something called a deployment, and a deployment, you can say, you give it a pod definition, which describes the Docker image that's going to be pulled down from your remote image registry. And you can say, I want 2 or 5 or 10 instances of this pod running. And that's called how many replicas you've got running of that pod. And we'll come back, we'll see deployments again, but this is basically you would create a deployment, and then Kubernetes would then create pods depending on how many replicas you said you wanted. A service. So because you can, with a pod, you can say, I want 10 of them, I want 5 of them, I want 1 of them, of this, like for example, say our web app. Pods can go away, they're transient, they can go away as you scale out, as you scale, you can create new ones as you scale out, as you scale back in again, they'll be deleted, so they're quite transient. So you need some kind of load balancing story. So in this example, imagine that these pods are our web image. We've created 3 pods, we've scaled out a bit. We want something else talking to it. You go via a service. So a service sits in front of everything, and that's how everything talks to each other. It provides load balancing, and a service kind of just it doesn't get deleted and recreated all the time. It's it's more static than the pods. And so a service could be spoken to. Another pod that wants to talk to these would go via the service to load balance, or it could be the outside world. Now, this diagram is very, very simple. In reality, you'd have like an ingress at this point, which controls how traffic can come into your cluster. But this diagram's just talking about the service. So conceptually, you can think of a service as a load balancer, which sits in front of everything, and that's how everything talks to each other. And we'll see that again shortly. A node is in your cluster. It's a machine. It could be a physical machine. It could be a bare metal machine. A cluster, the terminology of a cluster means a group of things, and in this case, it's a group of nodes. So it could be, as I say, it could be a physical machine, VM, or Raspberry Pis in this case. So how do we? There's a lot more different resource types. So we've dealt with the different resource types like service, deployment, pod. There's lots of other ones. These are. I'll just talk about these initially. So how do you actually interact with your cluster? How do you create these things? How do you do stuff with it? And there's a command line tool called kubectl. Some people refer to it as call it kubectl. Some people say kubectl. Some people say kubecontrol. I prefer kubectl, but they all mean the same thing. And so this is actually quite intuitive because generally it follows the form kubectl verb noun. So it's once you understand these different terminologies, like these different resource types, it's quite intuitive. So here, if we do kubectl get pods, this is the kind of output you get. So this lists out all your running pods. So it's how old it is, its status, that kind of thing. kubectl get services. So again, it's quite an intuitive command line. You've got a list of all your services. So these are, like, as I say, load balancing between all your different pods. Kube get deployments, again, we've got all the deployments. We can see here, we've got a column saying desired. So Kubernetes is, it really favors desired state. So you specify what you want your environment to look like. So how many replicas of the different pods you want. And so you've told Kubernetes the desired state of your environment, and then Kubernetes is constantly monitoring it to make sure that the desired state matches the current. So if they don't match, Kubernetes might, if this was less than the desired, then it would create some more pods. If this was more, it would delete some pods. So it's constantly doing this health monitoring to make sure that the cluster is as what you've requested in your desired state. So generally, even though you can use the kubectl command line to interact with Kubernetes, your cluster, you can create pods directly or create things from the Kubernetes command line. It's not very source controllable. Generally, it's favoured to use YAML files, which you can source control, and you can see changes over time in the same way as with Dockerfile. Like Docker files and Docker Compose files, it's all good to source control all your configuration. So this is an example of a YAML file. And we've got the kind at the top. So these different kinds, deployments, pods, services. Generally, all the YAML files would have the kind specifying what it's referring to. And in this case, it's a deployment, so we can specify how many replicas. So if, you could change that number and change it to 5, and Kubernetes would, when you apply that, Kubernetes would create 5 pods of this. Then you've got your pod definition. So this describes, and a lot of the stuff in here is very similar than what you could put in the Docker Compose file. So we've got the image. Now ignore this image name. This is my blog actually used to run on Google Cloud on Kubernetes. It's now running on Azure AKS. So this is quite an old image name, but this would be in the same ways with when we did Docker run, some image name. We did, in the Docker Compose file, you had an image name. This is kind of the same thing. We've got labels as well. So what you can, this is actually quite powerful. So you can specify labels which are just key value pairs. So where I've got name web env prod, those key value pairs could be anything you want. And then so that's associated with this deployment and pods. And then remember, I'll come back to the labels in a second. So this is an example of a service kind. Down here we've got selector. And so these are the same as the labels. And this is how a service knows what pods to load balance between. So bear in mind that these key value pairs could be anything you wanted. So you can really, it's quite powerful, and you can set up different, you can have much more complicated logic than this. So you can match what pods, the different services. So you can do things like having some services pointing at UAT pods, some services pointing at like production pods. And there's different ways you might not, within the same cluster or the same namespace. So we've got, you can specify namespaces, which you can have, you might have different applications within the same cluster, separated by namespace. So you might have a different namespace for UAT prod. So there's different ways how you separate those things out. But, with selectors, you could do things like A/B testing. So you might have, so there's lots of different ways you can use these labels to choose what you're load balancing between. So once you've got these YAML files, how do you apply that to your cluster? And again, kubectl you can apply -f of file. Dot means all the YAML files in the current directory, but you could specify a specific YAML file, and that will just tell Kubernetes. So it's not saying create me a service or create me a deployment. It's saying to Kubernetes, this is the new desired state for this resource that I want, that I expect the environment to be. So you're not explicitly saying create, you're saying this is my new desired state. And then because Kubernetes is constantly checking the desired state matches reality in like health monitoring, then once you've applied that new one, Kubernetes will then make it so. Where were we? Okay, so installing Kubernetes. So that's kind of like the fundamental. Obviously, there's a lot more to Kubernetes. There's loads more resource types, but those are the basic fundamental ones. So how do installing on the Raspberry Pi cluster? As I mentioned earlier, I've already pre-installed stuff in here, but I'm going to talk through how I did it. We're going to look at connect to the Raspberry Pis. So starting off, what operating system? There's an operating system called Raspbian, and this can be downloaded from this site. The Raspberry Stretch Lite, this is actually an older version. The newer version, it's called something else. Basically, they use like Stretch is kind of like the code name of that version. If I actually, can I go to it from here? Is that? The newer version is Buster, but I think this is like the previous version. You can, with that, you just download an ISO file. And then there's another tool called Etcher. So this is open source, Windows, Linux, Mac. A very, very simple GUI. You just select the ISO file you've downloaded for Raspbian and select the drive. So obviously you take the SD card, put it in your computer. You can then click flash, and that will then flash that ISO file to your drive. So that shows that there's no more slides, it's demos all the way now. Hopefully they work this time. But so we'll flash that to there, then you can put the SD card in your Pi. The problem is SSH isn't enabled by default. So, but you don't want to be connecting monitors, keyboard, mouse to each Raspberry Pi. So what you can do is, before you move the SD card from your computer to the Raspberry Pis, once you've flashed it, open up in Windows Explorer or whatever, Finder from Mac or whatever it's called, and get the files. So once you've flashed it, if you load up your Windows Explorer, you get a list of all the files in there. Create a new file called SSH, nothing else, just an empty file. That tells Raspbian to enable SSH by default. So then, once you've done that, you can then put it into the Raspberry Pi, turn it on, and it'll boot up and you can connect to it. It will be given a dynamic IP address, so DHCP. So you can find out what that IP address is by just going to your router, because most routers have, if we just go over, so this is the this is the home page, and so the dashboard for this travel router, and so when we first connect to it, there'll be a list of IP addresses for the different devices that are connected. But ideally, once you've done that, so you've got the IP address, you want to change it to a static IP address, just so your cluster is a bit more stable. So what you can do is, so I'm assuming everyone's heard of PuTTY, which is a client for SSHing in. This is a tool called Super PuTTY, which basically embeds PuTTY, but it allows you to have create different tabs. It gives you a bookmark kind of interface. So it's quite powerful, and you can set different layouts and stuff. So on here, I've given it a static IP address. So I'll show you how I've done that in a sec. So let's connect to the master node. So Raspbian's default username and password is Pi and Raspberry. So if I connect to that now, so I'm now connected to this top Raspberry Pi. Can everyone see that properly? So if I just clear the screen. So I'm now connected to that. When you first install it, it's got a DHCP. So we need to change that. And what you do is there's a file called dhcpcd.conf, I think. Oh, sorry, I can't cd to that. dhcpcd.conf, I think. Get rid of that. Oh, you can't really read that, that's annoying. Luckily, that most of the, so all that stuff you can't read because of the black background.
Black backgrounds are wrong. Black background.
Well, all those are commented outlines anyway, but none of this has changed. The only thing I've added is this block here. So basically you add that and you can give it a static IP address. So I've changed I've made 100, 101, 102, 103. And the subnet mask, the 192.168.8, is actually what was given this router defaults to. So I've added 100 to 103 for each of the things. And you can see in each of these, I've set that here. So that's probably the first thing I'll do, give it a static IP address, and that's literally all you have to change. The next thing is, let's just, the next thing is the host name of each of the Raspberry Pis is just Raspberry Pi, I think. So you need to change that. So there's two files you've got to change. You've got a host name, which would just say Raspberry Pi in here. So you change this over. So I've called Pi Master, Pi 1, well, these, Pi Node 1, Pi Node 2, Pi Node 3. So as I mentioned before, the master is the brains of Kubernetes. The different nodes are what your containers are running on. And you can, if you choose to, you can run your containers on master as well. Generally, it's not recommended because that's doing all the scheduling and all the brains of Kubernetes. So you change that file, and another one is just hosts. I think hosts or host. So again, this would have referred to that would have said Raspberry Pi, but I've changed this so it's separate because obviously you want to avoid conflicts between all the different Raspberry Pis. And though that's really all I've done. Once I've installed it, I've changed those. So we've got a nice stable cluster, but we've not got Docker or Kubernetes on there. So the next thing is to install Docker and Kubernetes. This super putty is quite nice because WinSCP is a quite popular FTP client. That's what I default to anyway, and it's got integration here. So if we right-click on one and go WinSCP, then the same password, Raspberry. Then you're straight on the Pi, and you've got you can copy files across. So I've got a couple of scripts which I've already copied onto there. So if we look at these scripts now, so I've got two scripts. I've got one that's install Kubernetes, and this you'd run this on all of the Raspberry Pis, and then init master after running this on the master, you then run init master to initialize it. So if we talk through what this is doing, so as I say, I've already done this in advance because you don't want to sit here and watch a script run because it's a bit boring. But so the first command, which is installing Docker, we've got curl getdocker.com. Now, so curl is just doing a get request, and if we go to getdocker.com, we can see that. That's actually just a script. So, which Docker are providing, and so if we go back to here, it's getting that script and piping it to sh. So that's actually running, that's executing that script. And then this one is basically saying, once we've installed it, Docker creates a group called Docker. We're just adding our Pi users to that group. Then Kubernetes recommends that you disable swap files, so that's just disabling swap files. I won't go into the details on why. And then here we're actually installing Kubernetes. So for those that aren't used to Linux, apt-get is generally one of the main package managers. So you can do apt-get install some piece of software, and it would pull that down from a remote software repository, registry. Instead, if you use Windows, you've probably heard of Chocolatey, it's that kind of thing. And then apt-get update updates your local list of remote software repositories. Kubernetes is installed on a third party on Kubernetes remote image registry. Not image registry, I don't know what they call it, remote software repository or whatever. So what they're doing here is they're basically downloading the public key for this their registry, adding it, and then it's basically it's taking this line, which is the name of their repository, their registry. Then it's adding it to a file in this directory. Now all the ones in this directory, when you do sudo apt-get, it's going to pull down the list of software from that software registry, and then we're doing apt-get install. So we're going to install Kubernetes. So basically registering another remote software registry, and then we're installing the kubeadm, which is the administration tool. The next bit, so once that's installed, this block is basically enabling some C group settings. So containers in Windows and stuff, it's new functionality, it's stuff being added on. But containers in Linux actually leverage native stuff in Linux. For example, C groups and stuff. So C group basically allows Linux to allocate resources to different processes. So things like CPU, memory, and stuff. And so containers running natively in Linux is actually, it's not a complete sandbox operating system or VM or something. It's just taking advantage of native Linux functionality. And that is just enabling some stuff around that. The next bit is, so IP tables is firewall stuff in Linux, and we're going to use something called the Flannel network add-on, which I'm going to talk about in a sec. And that requires us to set that setting, and then you've got to reboot. So we've got to do that for all the Raspberry Pis. Then just for the master, we've got to run init master. So we've now got this installed from the last one. And this is actually pulling down Docker images used to run Kubernetes, to manage Kubernetes. So Kubernetes is using some Docker images in itself. Then we run kubeadm init. And this bit here is required for this Flannel, this network thing, which we'll talk about in a sec. And then so that is going to initialize your cluster, initialize the master node. I'll come back to this in a sec. And this, remember how we said the kubectl apply applies a YAML file? So this, if we actually go to this URL, this is the Flannel network adapter thing, add-on, and basically when installing Kubernetes manually, there's a few different network add-ons you can choose from. Flannel is probably one of the most popular ones. You've got to choose one of them, but I kind of like, to be honest, when I was doing this, I looked at what the most popular one was and went with that one. So, but there's a couple of different popular ones, so I don't know the difference, I'm afraid. But you do have to choose which one you want to use, and so I chose from Flannel, and that is using that apply, which we've already looked at, to install that network add-on. As part of that documentation, it does say you've got to specify this as part of the init, and then you've also got to set that setting for IP tables. Going back to here, we can see that we've got another kind which we've not seen yet. So Kubernetes is very expandable, so you can have lots of different resource types. As a third-party developer provider, you can create your own resource types, and then so you can really Kubernetes is really expandable. So you'll see lots of different kinds depending on what you're doing. And with that, so that, like running those scripts, that's actually just that's installed Kubernetes, it's done all the stuff. So there's not that much we need to do. So hopefully now, the next step is, how do you authenticate with Kubernetes is the next bit. So that's this bit. So when you install Kubernetes, it creates in this directory admin.conf. And a config file specifies and something that looks like this. And I'll come back to this in a sec. But that specifies, that allows you to authenticate with your cluster and use the kubectl command to interact with it. So this creates an admin which has full admin rights, and it's copying it to the current user's home directory. And then it's setting some ownership. So that means from when I'm connected to PyMaster, then I can actually use the Kubernetes command line and interact with the cluster here. What I can also do is copy. Do you remember how in here, I've copied the scripts over. You can also copy that config file over. And in your users folder, you can copy this config file. And bear in mind, this has full privileges. So in a real scenario, you'd use something like Kubernetes supports RBAC, role-based access control. So you can, in the same way as with Azure and various other things, you can define roles for different users, but this is full access, just to keep it simple. So you can specify a list of different clusters. And this is the one that, so Docker Desktop for Windows actually now installs Kubernetes as part of the install, so you can have like a local development environment in Kubernetes in Docker. So that's what that cluster is referring to. This cluster, and you can see that we've got the IP address here of our master node. So this is referring to this cluster here. A context is basically, this is local only, and this basically allows you to almost bookmark different. So imagine I'm a developer, I've got access to various different clusters. You can create a named context which references, so this name, Docker Desktop, so that was created for me as the install, but let's look at this one instead. So it's given the name, given a user, and a specific cluster. So that cluster name refers to this, and this cluster name, which we've given it an IP address so we know where to look. The user refers to this list of users down here. So we've got, and this has got like the authentication key or token, whatever you want to call it here, which authenticates with the cluster. So all these contexts, you can switch, and you can actually right-click on here and go to, I won't go to it now because of, oh no, in fact I can here actually. So I can quickly switch between clusters here. I've actually copied, I've got another config file with all like client clusters in there, which that's why I didn't want to go there, but I've renamed that file just so we can look at this config file and I can interact with this. So this has only got, this is only really referencing this cluster. But this name here, we can see, we can switch between the different bookmarks. So you could quickly switch between that cluster, a cluster in Azure, a cluster in Google Cloud, or different clients, and you can bookmark them. Where I mentioned namespaces before, you can also add in here, so I could say that this bookmark references namespace, whatever you called your namespace. So you can have different contexts that you can swap between within the same cluster, but for different namespaces. So that's actually really, really useful. And you can switch from the command line, or you can switch from like this, the system tray icon. So that's how you authenticate. So I've copied this into my users folder. So this is in C users dan.kube config. And that means that from the command line now, I can do kubectl or k, because I've put an alias, and get pods. And that's now connected to the Raspberry Pi cluster, and said there's no pods because we've not got anything running. So the next thing is we could do get services or the various commands we saw before. So this is one that was already created, a default service. So the next thing is we need some of these YAML files for our website and for our console application. So again, here's one I made earlier. Where are we? 1 second. So if I copy these out now and put those in our, let's create a new, so you may hear the term with Kubernetes, the acronym K8S. Now this is, basically, it's just a shorthand, and it just means there's 8 characters in between the K and the S of Kubernetes. I think this, I don't know which came first, but if you've ever done any localization stuff with like new like web development, and you've seen I18N or L10N exactly, so it's kind of that whole thing where that's I18N is short for internationalization, and L10N is localization. They're using the same thing, so K8S is just short for Kubernetes. So I'll create that directory and I will paste the YAML files in here. So if we go back to VS Code now, Let's just close all these, don't collapse those. So in this KTest directory, so we've got the RabbitMQ, so with creating deployment, we'll just create one replica, got a label, and we're specifying the ARM version of RabbitMQ. So this again will pull from Docker Hub. So a lot of these concepts we've already looked at and very similar to the Docker Compose kind of stuff where we're specifying the image name and stuff. If you could put these different resource types in different files, but if you want to group them together in the same file, say like for this is RabbitMQ, we've got the service, we've got the deployment, we've got the service, we've got two services. You can use hyphen to separate out multiple ones if you want. So here I'm specifying the service, and we can see that I've got the selector RabbitMQ, ref RabbitMQ, so that's going to match labels ref RabbitMQ. I specify the port number, and we've got another service for RabbitMQ manage. So the same pod, but two different services. One for the using RabbitMQ for the messages like publishing and subscribing, and then we've got one for the actual dashboard, which hopefully will work this time. And our web deployment. What's that? Our web deployment. So in this one I've separated them out. So in fact we can get rid of we didn't give it a version number, so that label, so get rid of that. So it'll just use the latest version. And then this is quite simple. For our website, we're just saying we want one replica, and it's going to pull it down from Docker Hub, so the one we created before. The service, again, very simple. Like inside the container is expecting port 80. Outside the container, we will go to it on port 30,000. And the selector, so it's all very simple. There's a lot more you can put in these YAML. These are very basic YAML files. You can do stuff like with the deployments, you can tell it to do things like rolling updates, so you get hopefully zero downtime. So there's lots of extra stuff you can do in there. And then for the worker deployment, this obviously doesn't need a service because it's just sitting there subscribing. We're not accessing it from anything else. Again, I'm going to get rid of this version number. Let's just make sure I've done it from both. And again, this is just exactly the same concept. So I think now, hopefully, if we now go into that directory, we can do kube apply -f dot. So hopefully this is going to apply those to the cluster. So we can see this is running through, it's created all these because if we run this again, we can see that it's saying unchanged. So it recognizes that you're trying to apply something that's not changed. If I change something in here, for example, if I increase the replicas, then you could do kapply all of them. It would only check what's changed and increase the replicas, and then Kubernetes would then say, oh, we need 4 more, for example. We can now do get pods, and we can see that these are now running on the clusters. So we've got RabbitMQ, which is already running. Now, because I've run these before, it will do a Docker pull, but because it's already cached on the Raspberry Pis, it's not pulling down the full massive image. The thing is, because these could be running on any of these Raspberry Pis, when I've done it before, I don't know whether it's on the same one. So this is why these are probably running. I've been pulled down really quickly to the pod, but this is potentially running on another Raspberry Pi that hasn't already had the image pulled. But if we try it again, hopefully, so that's now pulled it down and it's running it. We can also do, if we do -output wide, and I might have to zoom in a bit here. Whew. And then if we do Docker wide here, oh, it's still wrapping anyway, but you can see that ignore the wrapping, you can see it says node here, so you can see what, we can actually see what Raspberry Pi each of these things are running on. So hopefully now, if we go to, if we look at the web service, Remember so the web service, we're saying we're going to access it on port 30,000. So if I go to the browser, so rather than doing localhost, I need to specify one of the Raspberry Pis. In a real world, if you're managing a Raspberry Pi cluster yourself, you put a load balancer in front of it, which is external to the cluster, which will load balance between all the nodes. But here I'm just going to directly access it. So it's 192.168.1.100 was the master, and it's already filled. So we go to that 3000, and hopefully we can see. It's the first time I've gone to it, so hopefully it's just ASP.NET warming up. Cool. So so this is now running on one of the Pis. Which one was it? Web is running on node 3, so it's running on the bottom one, this website now. And what we can do, if we do we've got kget pods. So if I go to worker, I can copy this, and you can do klogs. That's deprecated, logs. And that's now waiting for messages. So you can see that this is now connected to the RabbitMQ instance. Another thing I should point out actually is the service name we give it here. Remember with the Docker Compose file how the name of the service was the DNS entry? The service name here for the service type, that's the DNS entry. So because I've called RabbitMQ, I've given it a name RabbitMQ. Also, no, that's the deployment. For the service, I've given it a name RabbitMQ. Then what we did before with, do you remember how I changed this from localhost to RabbitMQ for Docker Compose? So this is still working in Kubernetes because it's using that name as the DNS entry. With the logs, you can also do -f for follow. So it's now waiting. So hopefully now, if I click on this and go back to here, we've now received this. Whew, it worked. This is the bit that failed when last time I did the talk because that battery ran out. It was actually when I did the Docker push. We didn't have a break in the middle. When I did the Docker push for the images, that failed, and then everything went terribly wrong. But it was okay. Right, so now we can just run this lots of times, and hopefully we've got these. If we move over to Slack, hopefully, so we've got some of these now. So that's worked, good. Some other things we can do, we could do where we did the klogs for that. We could do kexec minus, and you could say we're going to execute a bash prompt within that container. So now that container running on the Raspberry Pis, we've now got a bash prompt, so we can. Do you remember with the Docker file for the web? Do you remember how we made working directory app? You can see we're in app now. We do ls, all these files. So we've got worker.dll here. That was where we did the copy from the build. That's the artifacts that Docker.NET Publish created, and we've copied that into the current directory, which is this working directory app. So you can see we can very quickly get in there as well. There's, I don't know if I've got it installed actually. I wasn't planning on demoing this, but I may as well. There's a VS Code extension, Kubernetes, which allows you to even drill down. Sorry, I've got pins and needles. Oh, my leg's gone. There's a VS Code, so you can all your contexts, which I said before, or are these contexts, or these might be contexts, or the clusters. I think the clusters. You can drill down on the namespaces, and you can double-click and switch namespaces. We can look at the workloads. So we can see pods. We can right-click and do like follow logs. So that's the same as what we did in the command line. And that is, that was the web one. So we can see now listening on. You can do various things. So port forward, if you just need to debug, if you need to debug a specific pod, but you don't want to service anything, you just want to directly connect to it from your command line, you can say port forward, local port, remote port, and it will temporarily, when you control C, it'll stop that, but it'll temporarily allow you to port forward into and connect directly to a pod. So I think, for example, if I exit out of this now, Okay, get pods. So if I wanted to directly connect to this, I could do k port forward. And remember, k is my own alias for kubectl. So I could specify the pod directly. I could say, I've already used that one. Let's not do work, actually, let's do web. Forward. And 135, and it's listing on port 80. So that's now, if I go to 1245, 1235, in here. So that's now directly connecting, and as soon as you do control C here, that's quit out. So for debugging, that's really powerful. If you just want to say, what's wrong with this container? I want to directly access it. I don't want to go via any services. You might not have it might not be publicly exposed yet. So you just might want to be playing around with something, and you want to create a pod. You want to quickly get a connection to it, so you can test with it. So that's quite powerful. I still want to show script on that. Oh, kget nodes. So in the same way as we've got kget pods, kget services, we can do kget nodes. Oops. And this is listing all the nodes, and we can see some already. So you can see the state of your nodes. You can see what's in the cluster. And so you can see that all these commands are following a very similar verb noun kind of thing. Yes. So you can do. So if you wanted in this cluster, I've only got the default namespace, but you can do kget pods, and you can do all namespaces like that. So that'll list out for okay. Oh, spaces. So that'll now let me make it a bit smaller again. There, that's better. So that's listing out all the pods running, and you can see that this includes the system namespace. So we've got a whole bunch, like we've got the flannel pods, we've got a whole bunch of system stuff. You can also do, if you want to do, so say you're doing k delete something pod. In fact, let's do that. So say our worker one. Now remember how I said that a deployment manages, so you create a deployment, and that's checking that the desired state is what it should be. If I delete, say I delete the worker now, delete pod. So it's deleted that. Oh, and it's hanging for some reason. Should open another thing. I don't know why that's hanging. Okay, get pods. So you can see that it's, I don't know why that's hanging for a bit, but you can see that it's terminating and it's creating a new one. So you can see that the deployment, and there's actually more to it than this. You've got something called a replica set as well. So basically a deployment manager. I'm aware of going into too much detail, but you used to have something called a replication controller, and then they've added more functionality. And so for example, you've got the replica set, which manages how many replicas of your pods you've got, but then they've added this more functionality for things like this rolling update, the things I mentioned before. So that's part of the deployment. So generally nowadays, you wouldn't deal with a replica set, even though that's been done under the hood. You would generally create a deployment. But I just wanted to make, because I'm sure people watching are saying, well, what about a replica set and stuff? So I thought I'd throw that in as well. But generally, you nowadays deal with deployments, and then the replica set gets created for you, and then that manages your replicas of your pods. And RabbitMQ. So the web RabbitMQ. So the manage one, I've done it on port 30,001. So if we go to here, let's just duplicate on not that one, this one. If we duplicate this now and change this port. Oh, did I miss? Was it one? Ah, come on. Oh no, was it one? There we are. So again, this is the default one, so it's guest. And if we go to queues, no, I don't want to save it. So you can see that when we did the RabbitMQ. So yes. So here we can see that when I subscribed, I made sure that the queue exists. So that's created this my queue. If we go to it, we can see we've got a dashboard, and then if we just go to privacy a few times, then in a sec, hopefully, you can see that the message rates come in. Oh, there we are. So we can see that the message rate, because our console application would have taken the message off straight away, then there's no queued messages here. But if you've got, like, say, imagine this is like a really heavy workload, and you've got messages being backed up because your worker processes can't process them in time, then you might have a backlog here of lots of messages, and that's the kind of thing to watch out for to make sure you're not got a big backlog. And in this case, if you have, you can just spin up more containers to share out the workload. Showing that. What time is it? So one thing I was going to do, which I think I'm pretty much out of time now, is I was going to show increasing the replicas. So when you increase the replicas, Kubernetes would try and spread, for the same pod definition, it will try and spread out the containers across different nodes in your cluster. So the idea is that if you start unplugging Raspberry Pis or nodes, that your application will still stay up. I was going to demo some of that and increase the replicas, but I don't think I've got time because we're going to be chucked out very soon. Any questions?
Brilliant.
Oh, thank you very much.